Okay, hey y'all. We are going to do 10.2. Okay, so 10.2, we're still solving equations. Here they're going to introduce the fact that the inverse of multiplication is division. So if you see something multiplying with your variable and you actually want to solve for that variable, you need to do the opposite. You need to do the inverse. And the inverse of multiplication is division. So let's do a few of these problems right here. So I notice that I have 3x equals 27, and I'm trying to solve for x. So what you do is, because my 3 is multiplying my x, I do the inverse. Y'all, I could spend 10, 15 minutes explaining how this is the multiplicative inverse, and I'm really multiplying it by 1 over 3, and I don't feel like that's necessary for these first few problems. I just want it to be known that if my x is being multiplied by something, I need to do the inverse, which is division. What you do to one side, you have to do to the other. Those 3's cancel, which is what I wanted, because it leaves me with my x. Over here, I have 27 divided by 3, which is 9. Signs are the same, so it's a positive 9. Okay, let's do number 2. Here, my x is multiplying with a 4. I need to do the opposite of multiplication, which is division. And you only multiply by the number. I wouldn't multiply by 4 and the x, because then that also cancels my x, right? So here I've got my 4's cancel. It's funny how it goes behind it. My 4's cancel, and what I'm left with is x. Our equal sign. 24 divided by 4 is 6. Signs are different, so it's negative. Okay, y'all, problem 3. What I have is 8x equals 0. I need to solve for my x. I do the opposite of multiplication, which is division. What you do to one side, you do to the other. Left-hand side cancels, and I get my x is canceled, y'all. So my left-hand side cancels, and I just get x, my equal sign, and 0 divided by anything will always equal 0. And then let me plug this one back in. I just said x equals 0, right? That the value 0 for my x, what I'm saying is it makes this statement true. I had 8x equals 0, right? Well, I'm telling you that x equals 0. We've done this before. We plug in, right? I'm trying to see, is this true? 8 times 0 is 0. And guess what? 0 equals 0. You can actually do this for each and every single equation that we solve. Okay, so right here, this one almost looks like it's solved. It has x equals, right? Well, the only thing is it has an additional, excuse me, it has an additional thing going on with it. It is being multiplied by a negative sign, which technically means it's being multiplied by a negative 1. So we would do the opposite of multiplication, which is division. What you do to one side, you have to do to the other. And if you notice here, that canceled that negative sign, and all I have is x. 5 divided by 1 is 5. Signs are different, so it's negative. So just keep in mind that when I divide, I'm using the exact same number, and I'm using the exact same sign, okay? So this one definitely looks a little different. Here, my x isn't being multiplied by something, it's being divided by something. Well, the opposite or the inverse of division is multiplication. And what I do to one side, I have to do to the other. So what I do here is I multiply by what is going to cancel my denominator. And I notice that my denominator is a 7. So I'm going to multiply both sides by 7. I'm going to pull this over here, y'all. If you do 7 times x over 7, that is the same thing that I showed you with the multiplicative inverse, right? But here, instead of 1, what I have is my x. My 7's cancel, and I'm just left with x, which is what I want. 7's cancel, left with x equals 7 times 10 is 70. Okay, so this one looks even a little bit more different. You could actually just look at it this way. I have a fraction multiplying my x. It's a negative fraction. And I know that I do not want anything near my x. So I need to do the opposite of what's happening here, right? Well, what I would use is the denominator to cancel the other denominators. I notice that I have 2 denominators. So what I need to do is multiply both sides by a denominator that will cancel both denominators. Okay, so if I multiplied both by 5, if I have 5 here and I have this here, that wouldn't cancel the 15 because it's smaller than the 15, right? So I wouldn't use my 5, but I would use my 15. Now when I do this, what I have is 15 times a negative 4 over 5. That 15 can be written over 1, right? Now do you see I've got a 5 on the bottom and a 15 on the top? 5 divides 5 one time. 5 divides 15 3 times. What I get is 3 times a negative 4. Both of those are over 1. So I get a negative 12. But I'm going to do it slightly different right here, okay? So looking at my original fractions, I've got 15 multiplying this fraction. I'm just here going to go ahead and do my division or reducing, right? I'm reducing. And what I get is my 3, and then in parentheses, I have a negative 4x because that 1 on the bottom, you don't have to write that, right? Okay, equals. What do I get over here? Well, it's perfect, actually. 15 divides 15, it becomes 1. 15 divides 15, it becomes 1. The only thing I have on the right-hand side is a 16. Now, I've got 3 times negative 4x. 3 times 4 is 12. Signs are different, so it's negative. Don't forget your variable. Equals 16. I'm not done, though. Now my x is multiplying with the negative 12, so I need to divide by a negative 12. I'm moving right here, y'all. If you do that division, what happens are my negative 12s cancel, and I'm left with x, right? That's the only thing that remains, equals. Okay, so it looks like 16 and 12. I'm trying to think of the largest number that can divide both of those. And I believe it's 4. If I do 16 divided by 4, I get 4. If I do 12 divided by 4, I get 3. That's a negative 3, right? So what I get over here is a negative 4 over 3. That's the value of my x. Okay, that one's kind of all over the place. Ask questions if you need to, okay? So I notice that I have distribution. If I do that math, 4 times x is 4x. 4 times 4 is 16. Signs are the same, so it's positive. Y'all right here, remember, also distribution. Negative 1 times 2 is a negative 2. Don't forget your variable. Negative 1 times 16, well, 16 times 1 is 16. Signs are different, so it's negative. Right-hand side, I have a negative 6. Now we look, and I see that I have some common terms. 4x minus 2x is 4 minus 2 is 2. Keep and keep, right? And then I notice right here, I've got a positive 16 and a negative 16. Y'all remember what those are? They go to 0. I have my equal sign, and I have a negative 6. Still not done, need to divide. Left-hand side cancels. I get an x equals 6 divided by 2 is 3. Signs are different, so it's negative. Okay, great. If y'all have any questions, make sure you let me know, okay? Thanks. Bye. If it'll let me open everything. Oh, it almost let me. There we go.